Find the area of the region enclosed by the curves y equals 1 minus x and x equals y squared minus 1. Now, y equals 1 minus x is easy enough to graph. That is a linear function with a y-intercept of 1 and a slope of negative 1. So it's going to look something like that. But if we look at x equals y squared minus 1, this is written in the form x as a function of y. So we actually have to flip things around and think about what this is going to look like on its side. This is actually going to be a parabola that's opening rightward. If it was x equals y squared, that would be a parabola with a vertex at the origin opening to the right. But because it's minus 1, that actually moves it to the left 1. And so it's going to be a parabola that looks something like this. This is our x equals y squared minus 1. And this is y equals 1 minus x. And so here's the thing. We cannot integrate in terms of x. And that's for a couple of reasons. If we were to try and do that, we would have to break things up into vertical rectangles when we're doing our Riemann sum. And some of these rectangles go between these two curves, but some of them go between two different parts of this same curve. So it would be a bit of a mess. So what we're actually going to do is we're going to integrate, thinking about x as a function of y. We're going to write both of these with x as a function of y, and we're going to integrate with respect to x. So we're flipping everything around. It is a different ball game here. So what we need to do is we need both of these written as x as a function of y. And we already have that for this one, so we need to do it for this one as well. If we add x and subtract y from both sides, that gives us x equals 1 minus y. So those are our functions. I'm just going to rewrite this one as well, so we've got them next to each other. And we need to figure out where they intersect so that we know our bounds of integration in terms of y. So to do that, we set them equal to each other. And so we have 1 minus y equals y squared minus 1. And this is a quadratic equation. To solve this, we move all the terms to the same side. So this is going to be y squared plus y minus 2 on the right equals 0 on the left. We can factor this out. That's going to be y plus 2 and y minus 1. And that means that our two y values here are going to be negative 2 and positive 1. And that matches what we can see here, negative 2 and positive 1. So if we're integrating this in terms of y, you need to kind of turn your head to the side to think about this a little bit, but we are going to integrate from the lower y value, which is negative 2, up to the higher y value, which is 1. And our integrand is going to be the difference of functions, but functions of y. And we can see that in this range, in this interval, the larger function is the linear one, and the smaller one is the quadratic. So we've got to take the linear function, 1 minus y, and subtract the quadratic one, y squared minus 1, and we're integrating with respect to y. That's going to give us our area. So let's go ahead and do this. We can simplify everything on the inside. This is going to be 1 minus y squared plus 1 dy. And of course, that's going to be the same as 2 minus y squared dy. And the integral of that is going to be 2y minus y squared over 2 minus y cubed over 3, evaluated at negative 2 and 1. And partially because I'm running out of room and partially out of laziness, I'm just going to tell you that the answer here is 9/2. You definitely should be able to plug in 1 and -2 and take the difference. So I will leave that as an exercise for you to do to make sure you get that. But we should end up with 9/2 in the end.